Our next Our next topic in object-oriented software engineering is to deal with the system development. In the earlier lesson, we have dealt with what is system development. So, looking into more details about the system development, we have divided it into three phases. One is analysis, construction, as well as testing. So, in today's topic, we will discuss about transition from analysis to construction. So in this transition, the development methods divides the development work into different stages which vary from project to project. Formal analysis model may be required in one project while implementation environment may affect the system requirements in another project. So formalism during analysis phase is restricted to syntax and semantics of the static structure of the system. So, a formal technique is used at later stages during implementation. So, even though the boundaries between analysis and construction look vague, there are certain guidelines to be described during analysis and during construction as well. So, the analysis is independent of implementation. Thus, changes in implementation requirement do not affect the analysis result. That is, even if database management system is replaced during implementation, analysis model is still not affected. By the way, it says that because we have done it in different modules, when one module is not working properly, the whole system or the entire system is not affected in any ways. So here as an example, we have taken if the database management system is replaced by some other database management system also in the implementation, but the analysis model is still not affected. So that is the beauty of dividing it into different modules or components. The analysis model is application oriented. The work is carried out in an ideal world, that is, memory, performance, and fault tolerance requirements are set aside. The analysis model describes the elements of application in application related concepts such as service packages. So these service packages come up with different kinds of services, and each kind of service can be used at different levels or for different elements of the application. The analysis model should not be too elaborate as some of this work is adapted for implementation. So here the analysis model cannot be too elaborate, but it has to specify all the details that are going to be implemented. So given the properties of system development, one approach to rational system development is provided by our conceptual framework of object-oriented software engineering. So then next comes the requirements which are given as an input to the system development. We pretty well remember that the system development has got its requirements as inputs, and also the system is going to be generated as an output. So the primary input for the system development is the requirement specification itself. So as in how the system development is implemented or developed, the requirements play a very basic role in feeding its inputs. These requirements come from the user as to what are his expectations regarding this particular system that is going to be developed. So a new enterprise model is built where the computer-based information system forms an important part in the enterprise. The development of a new and changed enterprise is based on the existing information system. So here enterprise development can be viewed as a generalization of system development and aims to identify the problem areas and suggest alternative solutions. One result may be to introduce an information system. Enterprise development can be divided into following phases. So the phases of enterprise development are establish current state, enterprise analysis, the change analysis, enterprise design, enterprise verification and validation. These are the 5 phases that an enterprise development may be divided into. So coming to the current state description is a survey of the framework of the present enterprise, including its aims and problems. Functionally different activities within the enterprise are separated and analysis is made to find out what each activity contributes to the system. One activity may comprise several parts of the enterprise. Then coming to the enterprise analysis, it is an ideal model made up of present enterprise. So whatever is existing, we take that into consideration for analyzing what is going to be a future product. So coming to the change analysis, again it is a detailed description of what is the change between the present and what is going to be done next. So change analysis is a detailed description made of current problems and needs and appropriate changes suggested. This results in a change analysis model. So whatever we had in the existing system, what else is required to make it as a new system? What is the change that is acquired from the existing to the new system is what we call it as change analysis. We make an analysis of what the changes are going to be and make a detailed description of what the changes are. So next is enterprise design. Results from the change analysis which can physically be realized given the practical conditions of the organization. Now once change is being analyzed properly, if it is worth going for another system or another version of the system, we do take it to the design aspects, provided the practical conditions of the organizations are taken into consideration, provided the organization agrees on it, provided the organization is ready to take up these changes for the next version of its implementation. So finally, we have enterprise verification and validation. The new enterprise is verified against the initial intention and also validated in its new context. So what is the existing system? What is the new system that is going to come into picture? What is the difference? Whether the change has been analyzed properly, whether the change has been portrayed properly inside the implementation. All these kinds of things will be verified and also validated. Whether all the change requirements have been properly in place or not are to be validated. So coming to the administrative systems, the requirement specification serves as input data for the development of supporting information system. It is usually developed in a dialogue between customer and producer. It forms the basis for the decision to order the systems. Usually we collect all the requirements from the customer in a very formal or informal manner, and those different techniques, we use different techniques again to gather all the requirements from the customer to in a very formal manner or very informal manner also. So in administrative system development, the work to develop a requirement specification constitutes a considerable part of the development activity and is done in cooperation between the users and the system developers. Then coming to the technical systems, the requirements of the software system are given by the interfaces to the environment, that is, from sensors and actuators, where the specification can be derived from the knowledge of required structure and behavior. Earlier in administrative systems, we have seen that the requirements are being gathered from the customer to the producer. Here, the interfaces or the interfaces of the environment are trying to collect the information from different sensors and actuators when it comes to the technical systems. In some cases, the existing system document functions as a basis for development of requirement specification. This method is called as re-engineering. Now in this case, if the existing system document has been used to find out what the requirements are going to be, then in such a case we call it as a re-engineering. That is, we already know it and still we dig into the details of whatever we know. So that is what we call it as re-engineering. It is practically impossible to foresee all the requirements of a system during the introductory specification work. So when the work has started, when the requirements are being gathered from the customer, it is very much impossible or practically impossible to see that all the requirements have come into its place. Basically, because of that characteristic of software, we don't expect all the requirements to be at one place at the same time, that is at the introductory level. And so we see a lot of spikes rising up in software characteristics. Reason is that the moment the customer projects a change, there would be a spike in the software characteristic curve, wherein there would be not so many errors, and bringing down the errors and making it into a normal functional unit will again take time. So therefore we cannot expect all the requirements of the system to be explained during the introductory phase of the specification. Then finally, coming to the system as the output from systems development. We have already seen about the requirements as the inputs. Now let us see some output, that is the system itself. The output from system development is a set of descriptions which function as a basis of production in production department and as a basis for product description in sales department. So it can be either production in the production department or the product description in the sales department. So the same thing is functioning in two different ways, one in the production department and the other way in sales department. The final result is the program code which constitutes the final executable model and other related documents that users need to understand and use the system. Uses include persons and machines that interact with the system. Here it is not only the human beings who are involved in this particular category of users, but we also call the machines which are trying to interact with each other also to be users. Because whether it is a human being or a machine, we try to interact with the system. Then in such a case, the users are categorized both as persons or machines, whoever or whichever will try to interact with the system. The users can be operators involved in the process industry or the personnel involved in error correction and normal maintenance. Document and the product are the two basic notions which together constitute the description of the system. Here these are the two entities which will describe the system, that is document as well as product. The superordinate entity is the product, that is the system itself, consisting of a number of subproducts. Due to reuse, a product may refer to documents in other products. So here, as long as the product is one of the entity which describes the system, equally, the document also will have to describe the system. Whether you hold the product or the document, both of them will have to give you sufficient information regarding the system that has been developed. So this is a process in which a particular system is developed. It starts with three things: analysis, construction, and testing. The input for which is coming from the requirements and the output is the system itself.